In the past 10 years, development in the Research Triangle area has skyrocketed, and the face of downtown has changed drastically. Alongside the rapid growth, Black and brown people are being pushed out and replaced by white homeowners with much higher income levels. Higher incomes, higher home prices, and more white-collar workers tend to be associated with a particular kind of demographic change that pushes low-income or minority residents out of their neighborhoods. This is commonly called gentrification, the physical upgrading of the environment combined with the displacement of low-income, racialized residents in favor of higher socioeconomic groups. In this study, we wanted to explore the factors that contribute to the displacement of Black population in the Research Triangle. We were also interested in investigating where exactly this displacement occurs. We sourced our data from the Census Bureau's annual American Community Survey, which conducts a wide range of demographic surveys. We used census tract data in Chatham, Durham, Orange, and Wake counties. We looked at the college-educated white population, the population of several different education levels, the percentage of white-collar workers, the median income levels, median home prices, the percentage of children in private schools, and more. All demographic variables we used are framed in percentage point change between 2010 and 2017. The response is a binary variable that categorizes census tracts as either gentrified or not gentrified, based on the percentage point change in the Black population. We hypothesized that census tracts in which there is an increase in college-educated whites, an increase in median household price, and an increase in the amount of people who obtain a bachelor degree or higher will correspond to a decrease in Black population. We also wanted to be able to pinpoint the neighborhoods with the highest rate of incoming college-educated white people and the highest rate of Black exodus.
The univariate analysis through histograms of the predictor variables showed approximately normal distribution for all predictor variables. The response variable, gentrification, is a categorical variable with two levels, gentrified, which is denoted by 1, and not gentrified, denoted by 0. Because our research focuses on change in Black population, we use data on this change in each census tract to determine classification in gentrification. The distribution of the percentage point changes in the Black population across all census tracts, omitting any none applied in the dataset, shown here has a standard deviation of 6.76. The mean is very close to 0, so we use the standard deviation of 6.76 to determine a gentrification threshold. If the Black population decreased by 6.76% or more, the census tract was considered gentrified. According to this, our dataset has 246 observations that are not considered gentrified and 42 that are considered gentrified. The first question we wanted to examine is, where in the Research Triangle is gentrification occurring the most? We use spatial data to plot the gentrification variable by census tract. As you can see on the graph on the left, the areas that are considered gentrified are denoted by the color blue, and all the areas that are not considered gentrified are left blank. We also wanted to examine the impact of urban and rural character. An interesting finding is that comparing the gentrified tracts to urban areas, we can see that the most gentrified tracts are in or near urban areas. Many of these tracts are also in or around those city centers. This is intuitive and seems to align with the popular understanding that gentrification mostly affects urban neighborhoods.
Now that we have a better idea of where gentrification is happening, we wish to explore why. In order to get a sense of which factors are associated with gentrification, we chose to use logistic regression because our response variable, gent, only has two outcomes, gentrified or not gentrified. We used backward selection to find the optimal reduced model and then explored additional terms and interaction terms using k-fold cross-validation and drop-in deviance tests. We checked that our predictor variables were not correlated with one another to confirm that our model avoided collinearity. This entire process produced the final logistic model shown here. The intercept, -2.88, describes the log odds that a census tract has experienced gentrification when the percentage point change from 2010 to 2017 in college-educated whites, white-collar, no diploma, high school grad, and home price median is equal to 0, and the census tract is in a rural area. The model assumptions were satisfied, and the ROC curve we created gave an AUC value of 0.742, so the model fits the data fairly well. We use the ROC curve to determine a threshold of 0.143, which will prioritize sensitivity when determining if an area is gentrified or not. When considering the trade-offs, we believe that further research will likely be conducted on an area before making any policy decisions, so the risk of a false positive classification is not very high compared to overlooking a gentrified area and missing an opportunity to control the effects. Finally, based on the p-values, coefficients, and 95% confidence intervals, we determined the variables with the biggest impact in our model appeared to be college whites and rural. The log odds of gentrification are multiplied by 1.093 for each percentage increase in college-educated whites. The rural variable seems to have an even stronger impact. If the census tract is urban, log odds of gentrification are multiplied by 2.55. From this analysis, we're able to conclude change in college-educated whites and urban versus rural location are highly associated with gentrification.
Our study was motivated by two questions. Where in the research triangle does gentrification occur, and what factors contribute to the displacement of the Black population? The spatial data suggests a strong association between gentrification and urban character. Most gentrified tracts were in urban locales, and many were in city centers. Our initial hypothesis that census tracts with increases in college-educated whites, overall college-educated population, and median household price will correspond to a decrease in Black population was partially correct. Both increases in college-educated whites and increase in median household price increased the odds of gentrification. Classification as urban, however, had the strongest impact on gentrification, which aligns with our spatial analysis. We conclude that urban character of a tract, an increase in proportion of college-educated whites, are the most important variables in determining the displacement of the Black population. In our study, we focused specifically on the change in Black population to determine if an area was gentrified or not, but gentrification can impact a variety of different socioeconomic groups. For a more rigorous and complete understanding of gentrification in the research triangle, researchers should look into the Hispanic population, poverty statistics, public housing policy, and more. The first step to responsible development is understanding growth side effects. Further research would enable policymakers, NGOs, and developers to more fully understand and mitigate the impacts of gentrification on the local communities.